In the previous videos, we took a look at global and link local addressing, neighbor discovery, multicast, and duplicate address detection. In this video, we're going to take a look at how we get 2,000 or 3,000 hosts or a couple hundred hosts on the network and working with IPv6 with very little effort. As a review, let's go ahead and put some IPv6 addresses on R1's interface. And just to be clear, on R1, I wiped out any IPv6 information that he had previously, just to make sure we're starting with a nice even base with no hidden surprises. So I've got no IPv6s whatsoever addresses on any interfaces. That's great. And I'm going to hard code the MAC address, the layer 2 address on FA0/1. Why? That way when we see it in the protocol analysis coming up, we'll know exactly where it came from. Now, one other thing that I like to do is that if we don't want to use the EUI64 host ID from the MAC address, we can actually hard code that link local address. So that's what we're going to do here on FA0/1. We're going to hard code it with FE80::1 and specify that that's a link local address. And then we'll configure it with a global IPv6 address for this network. So now we're controlling 128 bits of these IP addresses, and we're not just saying take the EUI64. The last thing I'd like to do is just do a show IPv6 interface just to verify the pieces and parts. So here's the link local address, 128 bits worth. And it's a lot simpler because it's concatenated. It's shortened up because of all the zeros, and it's not using the weird EUI64 format for the host ID. And here's our global address that we also configured a moment ago. So everything's matching up exactly as it should. This multicast group, as we learned previously, is the multicast group for any device, whether it be a printer or a host or a router. Any device that's speaking IPv6 joins this group. So if a device needs to communicate to everybody else who's speaking IPv6, we send packets that are destined to that group, and those packets will be received and processed by everybody who's joined that group. And this is the solicited node multicast group for this host and his IDs. Now, what do I mean by that? We took a look at this previously, but here's a review. Our link local address, the last 24 bits, are all zeros and a 1. And so that is the solicited node multicast group specifically for anybody who has those last 24 bits. It just so happens, because I hard-coded both the link local and the global address, that the last 24 bits of the global address are also all zeros and a 1. So we have one solicited node multicast group that we've joined. It's a marriage made in heaven. If we had 20 or 30 different host IDs, we would have 20 or 30 different solicited node multicast groups which we've joined. And that's so the neighbors can discover and find each other. So one other kind of interesting thing is that by default, Cisco routers, they don't like to route IPv6. I shouldn't say they don't like to, but they're not configured by default to do IPv6 routing. So if you want your routers to route IPv6 traffic, which, by the way, would be one of the first things you'd do from global config on R1, R2, and R3, is you'd tell it in global configuration, I want you to be willing and able to run IPv6 unicast routing. See, IPv4, no problem. Routers are built from the ground up to do IP routing without being told to. You can disable IP routing, but by default, it's enabled. So we're just going to enable IPv6 unicast routing and global config on each of these devices. And now a special thing's going to happen once we issue this command. And we tell the router, you are now willing to route IPv6 unicast routing. How do devices find a router if they need one? Well, one way we can discover a router is by having the routers join a special multicast group. And that is FF02::2. So anytime a device needs to, for whatever reason, discover information from a router, it knows the multicast group to send to would be FF02::2. Because any routers have joined that, that's a great way to locate them on the network. So there's no magic to that. That's a default behavior in IPv6. So on a Juniper box, which has IPv6 unicast routing enabled by default, if you enable IPv6 on an interface, it's going to have joined that group automatically. On a Cisco box, it's only going to join this group FF02::2 if you've enabled IPv6 unicast routing. So let's take a look. Now that we've enabled IPv6 unicast routing, you'll notice there's one additional group, and that is our all routers multicast group. So when a router has an IPv6 address configured on an interface and it has IPv6 unicast routing enabled, what does it do? Well, just like a proud parent, it wants to tell everybody about the fact that it's alive and well and how it's doing. So it's going to go ahead and send out a special little message called an RA. It's a router advertisement, advertised by the routers. And this RA, I call it a little hoorah message, on a Cisco box, at least on this platform and this iOS, it sends it out every 200 seconds. So it basically says, hey, this is network 2001, DB8, 21, 111. And by the way, here's my layer 2 address if you need it for anything. And it sends those out periodically. So I'm going to turn on service timestamps so we can take a look at some debugs. And then we'll do a debug of IPv6 neighbor discovery so we can actually go ahead and see these. Now a client, how would we use these? A client who connects to the network, their Ethernet, they enable their interface, they can listen to these router advertisements and learn what this network is, the IPv6 global address space. And then once they find out what the network is, they can use EUI64 to configure themselves a unique host ID on that network. Now the magic is this. A device doesn't have to wait 200 seconds. We'll see one here eventually. But a device doesn't have to wait 200 seconds. Oh, look at that. We got lucky. So here's a router advertisement. It's being sent from the link local address on R1's FA0/1, which is FE80::1. We hard-coded that. And it's being sent to the all nodes multicast group for IPv6. So any device that's out there, every 200 seconds, like it or not, they're going to hear a router advertisement from the router. The most important aspect of the router advertisement is what network are you connected to. So any device here on this network segment can dynamically learn what the IPv6 network address space is without even having to ask for it. Now, 200 seconds, by the way, is a long time. In fact, if we go up here, it says it right here. So that's our show IPv6 interface command right here. And it's showing us that we're sending out router advertisements every 200 seconds. That's a long time to wait. So what happens when a client boots up and enables IPv6, they are going to send out a router solicitation, an RS. It basically says, hey, if you're a router, I'll send this to the All Routers Multicast group. If you're a router, I would sure love to know what network I'm on. And that way we can trigger an immediate router advertisement from the router. So here's my little friend, Mr. XP, and we're going to enable IPv6 on this interface. Now this interface here is the one that's connected to this network segment. So in the background, I've got some router advertisements happening periodically every 200 seconds on the route from the router's perspective. And if I enable, let me just bring up a couple of some space right here, and we'll go back and I'll enable this interface. And before I do, let me also capture it. So I'm going to capture the live feed as this comes up. Now the capture is running. Let me enable the interface. And now that's enabled, we should see a router solicitation, which is right here. And the router then responds to that router solicitation with a router advertisement. Now just for fun, before I bring up that protocol analysis, let's bring this full screen, Windows XP, and let's go to the command line and take a look at some of the config that we've generated. Let's go to Start, Run, go to Command, and here's the dark place, the command prompt. On that Windows box, the XP box that's directly connected to the same network that the router is. If we do an IP, let me just do a CD /, if we do an IP config, it's going to show us that it has an IPv4 address. Great, great, great. We don't care. And it also has an IPv6 address. In fact, it has 3 IPv6 addresses. It has the link local address of FE80::288, and that's because the MAC address on that PC was 0088 and then a whole bunch of 8s. So it flipped the 7th bit, inserted FFFE in the middle, and that's the new host ID. It also created an IPv6 global address, 2001, DB8, 21, 111, and then it used the EUI64 format there as well. Then the last trick that this device had up his sleeve is that I'm going to create another global IPv6 address, and this time I'm going to randomize. Now, why would that be important? Well, for privacy, if a device, as it's going out to the internet, always had the exact same host ID, the outside world, or anybody else for that matter, could profile and identify that specific host. By creating, every time it goes and gets a new IPv6 address, it's going to go ahead and source traffic out to the internet from this randomized address, and that's just based on the behavior of this XP box. This is Windows XP Professional Service Pack 0, no service packs whatsoever installed on it. So it's got the link local address, EUI64, it's got the global address, EUI64, and it's also got a global address on that same network segment with a randomized host ID. It also has a default gateway, and it says to use FE80::1, which is R1's address, as the default gateway. So let's put this down a little bit, and let me bring over the protocol analyzer to take a look at the play-by-play for that exact conversation. So let's take a look at the interesting relevant traffic to IPv6. Because it had an IPv4 address, this Windows XP box did a whole bunch of stuff with NetBIOS and trying to register its name and so forth. But from an IPv6 perspective, it asked the router for information. So it sent a router solicitation message from the unspecified address to FF02::2. And the most important part of this solicitation, and we can take a look at the type, it's in the Ethernet header, it said this is an IPv6 packet. In the IPv6 header, it says that we're going to have the next packet, or the next header is ICMP, and the ICMP message type is 133, router solicitation. So router 1 heard it, and as a nice little router should, it responded, and that response is right here. So there's our router advertisement, and it's being sent from the MAC address of the router to the multicast group address for FF02::1, which is all IPv6 speakers. In the Ethernet header, it points to the protocol 86DD in hex, which is IPv6. If it was IPv4, it would be 800 in hex. And if we take a look at the IP header, it says that the next header is going to be ICMP, and it has our source and destination IP addresses. And then in the ICMP header, it's got the router advertisement. And the most important part here of the router advertisement is this prefix that we're advertising. So if we scroll up just a little bit, here's our prefix right here. That's the network that the clients are connected to. And so the XP box is great. That's the network. I'll go ahead and use that and create my own host ID and join the party. It'll also get a default route as a function of learning this router advertisement, and it'll use the router that advertised this as its default gateway. So as we take a look at the other pieces here, what do we have to look at? This piece, neighbor solicitation. This is the duplicate address detection the XP box was using to figure out if his link local address was clear. So the multicast address for the solicited node address is FF02::1 FF, with the last 24 bits matching the host ID this PC is about to use. No one responded to that, so he used the link local address. And this neighbor solicitation was for the global address that had the last 6 characters of 816116. So he sent out that neighbor solicitation seeing if there's anybody using that IPv6 address. He didn't get a response back, so duplicate address detection succeeded there. And this is the duplicate address detection for his second global address, the one that uses the EUI64 format. That's why this solicited node address and this solicited node address up here are identical, because the solicited node, they both have the last 6 characters, which is the last 24 bits, the same in both of them. So in this video, we identified how clients on an IPv6 network, when they come online, they do their duplicate address detection. They also issue a router solicitation message. The router responds to that by supplying the IP address of the network that they're connected to. Using that, they can automatically configure. It's called stateless auto-configuration, their IPv6 address using EUI64 or whatever the vendors have chosen to use for that host ID to make it unique. They verify it's unique, and they're good to go. They've also got a default gateway of the router that provided the router advertisement. And now we have a functional network. This would be the same for 1 or 2 devices or hundreds of devices. They could all use the same process. And all we did to make this happen, we enabled IPv6 unicast routing on R1. We gave it an IPv6 global address here. It automatically did the router advertisements, and the rest of it's history. Thanks, everybody. I'll see you in the next video.